Okay, so now in this section, let's take a look into some optimization techniques that we can follow to improve the performance of our project. Right, so if I play the level now, you can see everything looks pretty much fine. But if I take a look into the FPS, you can see currently I'm having on average 40 FPS stable frame count. So this is actually fine, but I believe maybe we can improve this up to 60 FPS at least. It would be better, right? So how we can do that? And also this FPS count will be different based on your machine configurations. So in my scenario, I'm having sort of like a high-end PC. Therefore, I'm having this amount of frames per second count. Maybe you have a low-end PC. So if you have a low-end PC, then the frame count could be much more lower. Or if you have a very powerful machine, then the frames per count should be very high. But I think overall, to have some adequate performance overall, all type of PCs, it would be better if we follow some optimization techniques so that it will be better. Right. So how we can optimize the performance? Well, there are a lot of things, but mainly these frame counts of FPS will be affected by our dynamic response. Okay. So currently, as you have seen, we have multiple AIs that are spawned on the level. Both are pedestrians and vehicles. So these spawns actually caused a performance bottleneck. So that's why actually we have a FPS limit. But let's just say if I disable, for the time being, let's say if I disable pedestrian spawns, you will see there is a small improvement on FPS, right? So you can see now it's around 45 to 50 frames per second. Okay, but if I try to move, the FPS again drops. But if I am stable, the FPS increases. Right, now let me disable the vehicle spawns as well. And if I play it now, you can see we have a better FPS limit now. Around 55 to 60 FPS range is there. Okay, and that's one part, the effect to the performance, and also the scalability or graphic preset is also affecting for the performance. So actually graphic preset can be changed by the engine level. So I think it is up to the player to customize the graphic presets and come to the sweet spot. But in our scenario, we should not be able to focus on that part because that's engine level constraint. What we have to do is how we can control this dynamic response in a smarter fashion to optimize the overall performance. Okay, that's the goal of this section. Right, so I'm gonna enable the pedestrian spawns and vehicle spawns again, and you can see FPS drops. Okay, so you can see this green color FPS is the one that actually fine, but sometimes you can see it goes to red level, which is not quite good. Okay, right, so let's see how we can do some optimization. But first I will implement some spawners just for test our smart spawns. Then later on we will implement the algorithms to actually enhance the performance. Okay, so I'm gonna duplicate this map showcase and call this one as map underscore smart spawn. Open that up. Right, so here we have nothing, and we have around 45 to 50 FPS. Better. Right, now let's implement some spawn instances so that we can test these spawns. For that, I'm gonna first create a blueprint. Yeah, maybe here. Call spawners. I just create a actor instance called bp underscore spawn. Open that up. And here I need a box collision volume as usual. And then we can customize its size. I would say size, which is a vector. And by default, let's give some values like 500 by 500 by 100. In the construction script, we can set this one's box extent like this. Compile, set. Right, now we have this box. So I can paste it on the level and play it. And actually it is there, but I can't see the bounds. So maybe just for the time being, I'm gonna set this hidden in game as false so I can see the bounds. Right, now the next step is how we can actually spawn some actors here. Right, so first let's create a variable called spawnable actor class list, which is a type of actor class reference, and it should be an array. Both of them should be public variables. Assign it to a category called setup. Okay, now how we can perform the spawns. So first actually we have to get the spawn locations on this bound volume. We can do that. Right, I think we have done somewhat similar thing at the road. Yeah, here we have the function called get npc spawn configs. Right, so this has actually a lot of configs because it is actual spawns on the road, but in our scenario we don't need to go in this detail. We just need very simple spawns. Right, yeah, so in my scenario I will simply use a function called get spawn locations. I just need some location. Right, then we have to give the amount that I'm requesting, which is the integer amount, and also this will ultimately return some what do you call location list or vector list. So let's promote a new local variable called l underscore locations list, which is the type of vector array. Then let's take this amount and do a for loop -1. Right, and then I have to get some random location from the area. So our area is this box extend. For that I will create a new function called get random location from area, which is a pure function, and it will simply return a vector as a return value. Okay, then what I have to do is get the box volume, and let's get world location, and there's a function called get a random point in bounding box. We can use this one. And as the bounding box half size, we can split this struct, and we have to give the box extent. Let's get the box extent, split the struct, assign x and y, and the half size for z I will give 1. And this will be a location. And I will comment this one as get random location on bounding box. And also let's add some features to implement some debug as well. So I will say debug response, which is a boolean single variable, assign it to the setup category, mark it as public, assign it to subcategory called debug. And if the debug response is enabled, the debug response is enabled, it should draw a debug sphere on this location. Sphere radius I'll keep 30, line color maybe yellowish color, duration 5, thickness 3. And after that, this is for debug. After that, we can return the location. Compile it. Go back, and I can use this function over here, but I have to get the ground location. Yeah, I have to check for the ground. So I think at the road we have a function called check for ground or something like that. There is a one called trace for ground at spline point. This is for spline specific trace, right? But I need just a generic line trace. Yeah, so at this point I will create another helper function called check for ground, which will take location as an input and return a ground location as an output. So here we can perform line trace by channel, and the start location yeah, maybe let's get the location and break the vector, and here let's make a vector. We can give x and y as default values, but the c should be increased, so we can give some trace distance mark it as a public variable, assign to setup category, compile, save, give it a default value like 500, assign it to the C. Then for end also, we can use the same x and y coordinates, but for C, it should be subtracted. Like this. So we are subtracting C from the trace distance, and then we have the end value. Okay. And here the trace channel is visibility, that's fine. Yeah, it seems okay. Let's make a complex trace. Actors to ignore. Let's make an array for self. Draw debug type. Let's make a selection based on the debug spawns. If the debug is spawn is enabled, then it should be visible for duration, otherwise it's not. After that, we can take the output results, break it, and if it is a blocking hit, then we can simply return the location, otherwise simply an origin point, or else the given default location via the function. Compile save. Make this function as a pure function. Now at here, get spawn location function. After we get the random location from area, we can get the ground location by checking for ground. Similar to here. So let's check where this one is implemented. Okay, similar to here. And then let's add it to this locations list. And before adding it, we can maybe give some offset as well. Let's just say 50. And after the completion, we can return those list of locations as return values. And each call we have to clear this list. Compile save. Right now, at the begin play, let's give some delay, maybe 0.2, and then we can get the spawn locations. Amount, let's say spawn amount, and by default I'll give 3. This shouldn't be spawn amount, it should be simply amount. And then we can loop through this location list and we can actually spawn the actor. Now how we can spawn the actor? For that I will create another function called spawn actor, which takes location as an input, and we can call the spawn actor from class function, and at the spawnable actor class list we can first get some random array item and add it to here. As the spawn transform, I will split the struct and plug the location to there. And collision handling override, let's just say try to adjust location but don't spawn if still colliding. And this spawned actor we can simply return as the return value. Compile, save, go to here and call this function. Right now they should be able to spawn some actors, but first I have to configure it. So as the spawnable actor is, maybe I will use some NPCs. Yeah, vp underscore pet. Just use male blue, green, red, and maybe yellow. Compile, save, display. Now you can see we can spawn the NPCs. Also, let's try to do some debug and see how that actually works. Yeah, the location is being detected properly, but they can't move because I have to add the nav mesh volume. Nav mesh bound volume 0 by 0 by 0. Let's give it a box extent like 5,000, no, maybe 10,000 by 10,000. Okay, now it covers the entire area. And they can't move because I have to specify their AI state. Unregister NPC. Maybe this location, let's give it a higher offset like 100. Now that issue is gone. But they can't move because I have to specify their AI state. So over here, just for the time being, since I'm gonna spawn the NPCs, I will cast this to I don't even need to cast. I just simply get NPC AI system, and if this is valid, if this is a valid reference, then I can simply set AI behavior to, let's just say, now we don't have AI behavior, right? We have to define some random movement AI behavior. So let's quickly do that as well. So at the first, at the data enums NPC AI behavior, I will add another AI behavior called roam, which is simply roaming to some random location. Then let's go to the character blueprint NPC base AI behavior tree, and here let's add a new sequence that has been guarded by a blackboard key base condition, and the condition is basically if the AI behavior is equal to roam and non-value change self, we have to execute this sequence. Okay, and the sequence is basically moving to some random locations. Okay, so how we can move to random locations? So here we got move to target location. Which actually take the target location from the blackboard element and try to move. So that means we have to create another task to get a random location. Or maybe even a service would be fine. Service would be a good approach. So here we have the get target location service. Which actually take the define target location from the NPCI system. Maybe let's create a new service. New service based on blueprint base services. I'll call this one as BTS underscore NPC. No, let's just simply say get random target location. Okay. Right now we have to do somewhat similar implementation like this. Okay, right, first let's get the receive activation AI, and this activation AI, yeah, activation AI, that was fine. And then we can get a random location. There is a function called get random reachable point in radius, and here I have to first, yeah, let's promote this into variables on a controller and controlled pawn, and then from the control pawn let's get the actor location, that's the origin. And the radius can be parameterized. Just for the time being, let's just say public compile 1000. So I need to category called setup, and then we can simply set this one as the target location, but for that we need the blackboard key selector. Let's just say bb target location, which is blackboard key selector public, as I need to set up. And this key selector, let's set blackboard value as a vector, which set this random location like this. And after that we are simply notifying it as finish. I can't actually finish the execution because this is a service, right? So this will simply set this target location. Now at the BT NPC, I can assign that service here like this. And as the target location, I have to select the target location. And after that, I can simply use this same task, which is BT NPC move to target location, which actually read from the target location blackboard value and go to there. Right, now at the spawner I have to set the eye behavior as wrong. Save. Now let's play. They can't still move. First let's try with the one NPC, and I'm gonna check for the behavior tree as well. Let's play. No. Okay, you can see actually it has the correct path. It is actually executing the roaming path, but why it can't move? Let's try to debug the target location. And I'm gonna disable the debug for spawner. Yeah, I think it can't identify the target location properly. That could be the issue. Maybe let's try to print this value. Okay, maybe not printing. Let's try to actually draw debug sphere. Okay, you can see actually it is been able to detect the location, but it can't move. The move to target location. Right, this is the issue. Actually, it is checking the AI behavior is move to target location or not. But in my case, it is wrong. So that's caused the issue. Right. What we can do is maybe just for the time being I can disable this check, or else I can use two checks. Even one failed, then we can go in the other path. But actually this one is finishing it by aborting it, so we can't do dual checks. Either we have to improve this function, or just for the time being I'm going to ignore this. Okay, compile and save. Now let's play. Okay, as you can see now they are being able to move, and also each time the NPC is been able to detect a new target location and move it like that. Okay, so I'm gonna debug this one, disable this debug. Also I can disable this draw debug sphere as well. Right now they can simply move. This is just a basic feature that I want. Okay, and maybe let's try with 5 NPCs. Okay, all of them can spawn and move. Right, now I just want to show you how the FPS affect based on the NPC spawns. So currently you can see we have a very low FPS, which is around 40. And now let's just say if I duplicate this, let's just say we have now 4 elements. If I play it now, you can see again we have very low FPS and we have NPC spawns everywhere. And higher the NPC spawns, higher the FPS drops. For example, let's just say spawn amount is 100, extremely massive number. So you can see even it takes some time to load the level, because those actors should be spawned dynamically, and you can see FPS just dropped, right? So it is on the red level. And also you can see some of the NPCs even can't move because the computation can't be performed properly for each NPC, right? So you can see this is the issue, and you can see there are a bunch of errors as well. So probably there are some memory issues because we can't register all the NPCs at once, or maybe we can't unregister them at their own destruction. You can actually check for this one. Yeah, you can see actually trying to read property level manager. Yeah, it can't do that. So maybe what I will do is let's add some is valid over here, because sometimes even the initializations will fail. Okay, now let's play. It will take a while to spawn, but even though they can't move and the FPS drops. And if I reduce the NPC amount, let's just say just for the time being 10, now it will load properly, but the FPS will be dropped around 36 FPS. Okay, right. So in the next tutorial, let's see how we can enable dynamic spawns, which means we are not spawning all the NPCs at once, but we need some algorithms to spawn the NPCs in smart fashion, and we have to despawn them as well when they are not required to be in scene. So let's see how we can do those stuff in the next tutorial.